Hello everyone, welcome to another video from AGIS Associates. Today we're going to be looking at how do we georeference CAD files in ArcMap. Now we've done this in ArcGIS Pro and several of y'all wanted to see the same process and how it works in ArcMap. So that's what we'll be covering today and talking about. So what is georeferencing? What do we mean by that term? Well, it's really the way in GIS we take all of these features that we're trying to display in our maps and our layers and our feature classes and whatnot and tie them back to a real world location. This is an important part of GIS because it's really what allows us to overlay multiple layers from different sources so that we can see them come in the right location in relationship to one another. And we typically do this by putting that data into a real world coordinate system, be it a geographic or a projected. So your geographic would be things like latitude and longitude, WGS84, which is the native coordinate system for the US GPS satellite constellation. So when you're out with your GPS unit, with your smartphone or whatever, collecting data, that's what it's using, that WGS84, and that's an example of a geographic coordinate system. Or we can put data into a projected coordinate system. Like here in the United States, we have local state plane coordinate systems for each state in the US, or it could be the Universe Transmercator System, UTM, could be WGS84 Web Mercator Auxiliary Sphere, which is another projected coordinate system. So that's what we're talking about when we're mentioning or referring to georeferencing, that tying of all these features back to a real location on the Earth's surface, which we identify using either a geographic or projected coordinate system. The issue you run in with a lot of CAD data is that it's not georeferenced, that it's not tied to a real world coordinate system. It's in a coordinate system, but that's usually a local coordinate system or an assumed coordinate system. And that's largely because most engineers, surveyors, landscape architects, and so on that are creating this CAD data that we want to pull into our GIS, they're project focused. They're looking at one specific project. It's, some road realignment, or maybe it's a new water treatment plant or a new building site plan or things of that nature. They're not really worried about how does that fit into the rest of the world like we are with GIS. So as a result, a lot of CAD data is not georeferenced. Now that's slowly changing as more and more data is being collected with GPS or GNSS units, but we still encounter it from time to time. So how do we do that? How do we take non-georeferenced CAD data and turn it into georeferenced CAD data? Well, first, we've got to know where we store this data. If we're working with shape files or the old Esri ArcInfo coverages or CAD data, we're going to have a PRJ file that gets associated with that. And the purpose of the PRJ file is to tell Arc what coordinate system those data types are in, whether it's the shape file, the coverage, or the CAD file. Now, I know that in AutoCAD, Map 3D, Civil 3D, you can actually assign a coordinate system to the file in the drawing, but Arc can't read that. That's in a proprietary part of the DWG that Esri can't read. So even if you've assigned it in the drawing in Map 3D or Civil 3D, Esri can't read that. So it needs that associated PRJ file. And I know I'm referencing CAD, AutoCAD, DWGs, but this all applies to DXFs and Microstation DGN files too. So this covers the stuff I'm talking about, goes across the board. So as I said, if your shapefile or coverage or CAD file is created in a real world coordinate system, you'll also need an associated PRJ file, a separate file that tells ArcMap this data is in this coordinate system. Without it, it's going to come in or assume that it's non-georeferenced. You'll get an error that says it's missing a spatial reference when you add it in, and we'll see that when I do the demonstration here. If you're working with raster files, images, be they scanned images from, say, plats or maps, or whether they're aerial photos or whatnot, the coordinate system is going to be stored in a couple of different locations depending on the file format. You may have an AUX file, or maybe stored in the file header. You may have heard of GeoTIFFs, so that would be in the file header. That's where the projection information, coordinate system information is to be stored for those. If you're working with the Esri's geodatabase, then of course all of this is actually assigned directly in the geodatabase, and that's where the projection information is going to be stored. So if you do have a shapefile or a CAD file that was created in a real-world coordinate system, you are going to need that PRJ file for ArcMap to understand what coordinate system it was created in. So to create that PRJ file, we're going to use the Define Projection tool that you'll find in Arc Toolbox. It's going to be in the Data Management toolbox and down in the Projections and Transformations toolset. This will create that PRJ file for your CAD file, for your shape file, coverage file, whatever. It will generate that if it is missing. Now the key here is the CAD file must have been created in a real world coordinate system, meaning it must have been georeferenced. So this doesn't take a non-georeferenced CAD file and suddenly make it georeferenced. But if you know the CAD file, be it DWG, DXF, or DGN, was indeed created in a real world coordinate system, like WGS84 or your local state plane coordinates or UTM or something along those lines, this will generate the PRJ file that ARC can then read and know what coordinate system that CAD file was created in. But again, the CAD file must have been actually drawn and created in a real-world coordinate system, not in an assumed coordinate system, local coordinate system. It's got to be in a real-world coordinate system for this to work. Just generating the PRJ doesn't magically georeference the CAD file. We'll be talking about how to take a non-georeferenced CAD file and georeference it next. So, if you do have a CAD file that is not georeferenced, there are tools in ArcMap that will allow you to georeference it. We start by opening the Georeferencing Toolbar. This is one of the umpteen million toolbars that ArcMap has, right? This toolbar can be used to georeference CAD data as well as raster files. So if you scan a hard copy map or plat or design plan, you can also use this tool in the same basic techniques to georeference that scanned image in there. Or if you take a picture with a drone and it's not georeferenced, you could use this to do that. Okay, but we're going to be talking about how to do this with CAD files. What this allows us to do is take that CAD data, put it in the right location in relation to our data, basically back into that real world coordinate system. Okay, so we're going to start by getting it in the general location, right? So we're going to take that AutoCAD drawing or Microstation drawing and get it up kind of where it's supposed to be, assuming it's coming in down in kind of what I call Never Never Land, right? So first thing we typically do, we add the CAD file, we zoom into the area where the CAD file should be in relation to our data, and we're going to then go fit to display, right? So we're going to move it up and it's going to appear close to where we need it. Once we get it in the general location, then we can start doing some minor tweaking. If we need to rotate it to left or right, we can do some slight scaling to get it to fit if need be. Depends on how far it is from matching up to our existing data and how different things are. But we can use the tools as you see here. You can see the fit to display tool. Now you can see where it says flip and rotate, and we can rotate left and right. You'll also notice up on the toolbar itself, there's a drop-down box which contains a rotate tool. a shift tool and a scale tool. And so we're going to use those to get the data pretty close. Once we get the data fairly close, then we're going to start picking what we call displacement links or control points. So what we do is we pick a spot on our CAD drawing, and then we're going to pick a corresponding spot in our GIS data. And we can pick up to 2 control points when georeferencing CAD data. If you're happening to georeference an image, raster file, you can pick as many points as you want. But when working with CAD data, be it DWG, DXF, and DGN, you're limited to 2 points. And what this is going to do is shift, scale, and rotate the drawing to fit in your GIS. Now I should add, or mention rather, that you're not actually editing the CAD file. ArcMap doesn't allow you to edit CAD data. What you're doing is working on generating a separate file, a world file, that tells Arc when you display this CAD file, you need to move it up to this location, rotate it this much, and scale it by this factor, right? To make it fit. It's not actually editing the CAD data. When you open the CAD data in AutoCAD or Microstation, whatever, it's going to be the same. It hasn't moved or changed because, again, ArcMap cannot edit CAD data. So here's an example you can see of us creating those displacement links using those control points. So I've picked 2 points, one on the northwest side of this subdivision we're trying to put in, and one on the southeast side. Now, because we can only pick 2 control points, I have found it's best to try to pick 2 that are somewhat diagonally opposite of one another, because certainly there's other locations here we could have picked. Instead of the southeast corner down here, we could have tried the southwest corner and matched it up to here. But the northwest and southeast are linear from one another, which really won't give us a good scaling fit or rotation there. Alternatively, I could have picked up here on the northeast side and matched that up. Again, more linearly direct. And again, won't give us quite the scale and rotation solution that's going to give us the best answer. So again, I find picking 2 that are diagonally opposite from one another, as the example shows here, seems to work best. Could I have picked down on the southwest and northeast side and match those instead? Yes, I could have done those. It really doesn't matter which one I picked. You want to pick the one that gives you the best fit, and you can certainly test that and see which ones work for you to give you the best solution to making the CAD file fit. Now, I'm going to tell you, typically you're not going to get a perfect fit because, well, your GIS data covers a much larger area. It was created in a real-world coordinate system. So the relationships in your GIS data are not going to be, I don't want to say as tight as those in the CAD data, because not all CAD data is perfect by any stretch of any imagination. But typically, because the CAD file's in a smaller area, it's not going to be as, well, it's not going to be as distorted as some of your GIS data. And that's not to say your data is not good or clean. It's just you're dealing with a lot larger scale than what the CAD file is based on. So don't expect a perfect fit. So we're just going to try to get it in the right area. There's other tools. Once you have got it georeferenced, then you can convert it into GIS, either as geodatabase feature classes or shapefiles, and then you can use tools on the spatial adjustment toolbar to refine the fitment of the data. We're just trying to get it in the ballpark with these tools. So that's what we'll be doing. So with that, we're going to jump into ArcMap and do a quick demo of what we've just discussed so you can kind of see how this works in action. Okay, so we're in ArcMap now, as you can see. We have some basic layers. We have city limits, railroads, right-of-ways, and parcels. And what we're going to want to do is we have a CAD file that is a new subdivision that is going into this area. And so we want to bring it in and make sure it is in the proper location in order to update the parcels layer and right-of-ways and things of that nature. So over here in the catalog window, you'll see here's the CAD drawing we have, symbolized by the blue icons, as one would expect with a CAD file. And inside, you'll see multiple feature classes, annotation, multi-patch, a couple of points, a couple of polygons, and a polyline feature class. Now, to georeference the CAD file, we don't have to do each feature class individually or bring the whole drawing in at one time. I find it best to bring in a limited amount of data from the CAD file. Otherwise, it can get confusing. CAD files can often be very cluttered with information and just can distort what you're trying to do or cause confusion. So I'm just going to bring in the one feature class into our map. Notice as we do this, we're getting that the data source is in an unknown spatial reference. What this indicates is that, or from an Esri perspective, there's no PRJ. So as far as Arc is concerned, it has no idea if this CAD file is georeferenced or not. So if I click OK to this, it's just going to go ahead and display it in whatever raw coordinates are in the drawing file. So I'm going to click OK. You'll see it appears up here in my table of contents. I can expand it. You can see the rendering it's done. So what I want to do is go ahead and zoom down and see where is it showing up, because I don't see it anywhere here. So let's go ahead and right click and zoom to layer. And here we can see it now. What I'm going to do really quickly here is go in and adjust the symbology so it is something that we can see better. So let's just do a single feature. The orange is not bad. Okay, and apply that. Is that good enough? Let's make it a little thicker, just so it stands out a bit more so you can see it better. Okay, so now you can see the CAD drawing with the new symbology. Pay attention as I'm moving my mouse to the coordinate readout down here at the bottom right-hand side of ArcMap, and look at those values so that you can see that they're in the 500,000 X and 500,000 Y range. I know it's a little above that, but you get the kind of point. Anytime you see data from CAD that's in kind of that consistent X and Y format, so 5,000, 5,000, 10,000, 10,000, 20,000, 20,000, 100,000, 100,000, 500,000, 500,000, you get the idea. That's a good indication that that data was created in an assumed coordinate system. That's not a real world coordinate system. Of course, if it's down close to 0, 0, that would be another giveaway. But we can see that this is definitely not georeferenced, at least not with our data. So we're going to need to georeference it. So what I'm going to do now that I've seen that it actually brought the data in, it's displaying, I'm not having issues with that, I need to zoom in to the area that this file is supposed to be located at. So I already have a bookmark for that. You hopefully will know where within your data this CAD file is supposed to be. One would expect if you're the one maintaining the data, you would be aware of that. So I've gone ahead and I've zoomed in with my bookmark to this location. This is where it's going to be. The next step I need to do is turn on my georeferencing toolbar. So I'm going to go up here in the gray area where there's no other toolbars and right click. This brings up the whole list of all the toolbars that are available in ArcMap. This is just one way to do this. So there's georeferencing, turn it on, you can see it brings in the georeferencing toolbar. Another way to do that would be to customize toolbars and pick it from the list here. It's the same thing. You know, with ArcMap, there's always at least 2 ways to do everything, sometimes 3 and 4. But here are just 2 ways to turn on the georeferencing toolbar for you. So I've got the toolbar on. You can see it's gone ahead and picked up the CAD file that it's going to be georeferencing. Remember, this works with not just CAD files, but with raster files too. So if you had more than one potential layer that you could georeference, you would have a pick, the pick list here of which one you wanted to work with. Okay, I only have the one, so we only get the one. So my first step is to go ahead and zoom in. I know it's got to fit in this parent parcel. What I like to do is try to zoom in a little bit more so that when I do the fit to display, which is going to be the next step, that the drawing fits kind of inside the parent parcel. So I'm going to just kind of zoom in so most of the display area is inside that. And now I'm going to pick fit to display. And I'll zoom back out a little bit. Okay, so now that we have the drawing file displaying in the general area, right? It's not a perfect match yet, but it's in the general area of where it needs to be. And you can see how it kind of fits, right? Here's this back line, matches this back line. You can see this kind of zigzag up and down, kind of follows this zigzag up and down here. This curve here kind of matches the curve of this right away here. So we're definitely in the right location with the drawing. So from here, if I wanted to try to get it to fit better, there are these tools here. I could rotate it, shift it, or scale it as needed. So, I can go shift it, say 100 feet, enter. So it's going to shift it. Now that shift does it both on X and Y. So it got it in there. That's fine. Actually, this is probably good enough. You could also continue to do a fit to display as you change zoom scales to get a better fit. But the goal really is to try to get it inside of, and this is what I found works best, inside of the area that it's supposed to fit in. In this case, the parent parcel that's being subdivided for this new subdivision. Okay. So this is good enough for what I need. So at this point, it's time to start picking my displacement links with my control points. So I need to figure out what those are going to be. As I said earlier, it's best to go with points that are diagonally opposite from one another. So we could go with this corner and one of these corners down here, or this corner and this corner up here is probably going to give us our best fit. I think I will do this one and that one. No particular reason I'm doing that over these here. I like those. I should get a very similar result if I did this one and this one too, but this kind of gives me a little bit more total coverage of the entire thing. So that's what I'm going to do. Now, if this was an image I was trying to georeference, remember you can pick more than 2 control points for an image. So I could pick here and here and here and here and here and match those up accordingly. You can pick as many points as you want. Then if I had like something more in the middle, I could pick a couple of points in the middle to kind of control the center a little bit better. But even when georeferencing an image file, you want to pick points that are kind of opposite of one another or outside on the outer edge to get the best solution, the best fit for this. So let's go ahead, start picking our control points. We'll start up here in this corner to match these up. And again, I kind of like to zoom into that location to get the best fit. So I'm snapping to the right locations. So I've zoomed in. Now notice we've got this little jog down here, right? But that matches this little access easement that's up here. So we can fit that in. I just want to make sure I snap this corner when I pick it to that corner here and not accidentally grab this one up here. So go over here to the Georeferencing Toolbar. I'm going to pick Add Control Point. I've got my snapping enabled, and this is an important thing. Make sure your snapping is set accordingly. And I'm going to go here and snap to that corner, the endpoint there. So notice it put a green plus sign with a 1, indicating that's picked that point. And then I'm going to go up here to this location where the road right-of-way and the parcel boundaries intersect one another, and pick that. And notice it put a corresponding red plus with a 1. So this green plus with a 1 matches to this red plus with a 1. So now that's control point number 1 that's been picked. Now I'm going to go ahead and go back to my bookmark and then zoom in to this location here to pick my next control point. I'm going to match this corner to this corner. Make sure my Add Control Points tool is still active, which it is. Again, I pick first in the CAD data, and then I'm going to pick the corresponding point in my GIS data here. So again, we've got the green plus with a 2 and the red plus with a 2, knowing that those two correspond. You can look at those displacement links by clicking on this button up here, which is View Link Table, and it's going to tell you what the matching. The source would be your coordinate in your CAD data, and then the X and Y map would be the point in your GIS data that you're mapping or matching it up to. Because we're only doing 2 points, we're not going to have any sort of residuals. You only get that when you are doing a raster file and picking multiple control points. And then it starts calculating the amount of skew and things that are going to happen as a result of that. I'm going to turn that off. Zoom back to my bookmark so I verify my control points are in there. Now that that's done, I'm going to go ahead and update my georeferencing. So this is going to generate a new file, a world file. It's got a WLD extension. And what this does is tell ArcMap, when I add this drawing in the future, automatically apply this amount of shift, rotation, and scale to the display of the CAD file. It's not physically editing the CAD data. This is not going back in the DWG file, DGN, or DXF and editing the coordinates, because ArcMap cannot edit a CAD file. It's creating an external file that is only used for the display of that data, so it comes in the right location. Okay, so sure, I'm going to save it, and then hopefully if I refresh my display, there we go. You can see it now pops in, and it's scaled, rotated, and shifted to fit with my data. Now, we got a very good fit here. This is not always typical of what you will see when you do this. You may find that things are slightly off and all that. Again, like we talked about, the CAD data and GIS data are not created the same way, so there's not going to be the same scale factors, transformations, all that get applied. So a perfect fit is not always the case. There are tools. Once you get this georeferenced in here, you could convert the CAD data into a shapefile or geodatabase feature class. And then there's another toolbar called the Spatial Adjust toolbar here that allows you to then make adjustments to the data once you've converted it to a shapefile or geodatabase feature class that actually will allow you to move and adjust and hold things in place to make it fit better with your existing data. We're not going to get into that in this video, but just know that it is possible. So now you can see we have successfully georeferenced this data. It generated the world file. So let me bring in my Windows Explorer here. And we can see the world file that it created. And here. So we scroll down into here. Where's the northern subdivision? So there's the DWG. There's the world file that it created, which, let's see if I can... I'm going to try to open it, but I don't see... Oh, open with. There we go. At the top. Show more apps. And let's open that in Notepad just so you can see the text file that gets created. Okay. So here you see it generates a text file of coordinates that match up, that then apply rotation and scale in transformation or translation to the data. So take this coordinate, right? These were the coordinates that we saw originally when we were moving our mouse down when we first added, right? The 500,000 values. And this coordinate here should match up to this coordinate here in our GIS. This coordinate here will match up to this coordinate here, right? So it matches where those displacement links were that we picked and where they should go. Okay. Now that we have the world file, we could go ahead and create a PRJ file now that it's georeferenced. So we go into, say, our toolbox. And under, so there's data management. Scroll down to projections and transformations. And there's the define projection tool. This creates the PRJ. So I click there. I'm going to input my data set, being the CAD drawing we just did. And the coordinate system that I just georeferenced it to will be based on the layers that I picked. So that's that one. And go OK. And why did it fail to execute? Let's see what this error means. Oh, because the CAD file is open is why it won't create the, so I'd have to remove and then create it, but you get the idea. This is where you would go to do that. Now that I have the world file, let's see if it'll actually let me, now that I've done that, let's go ahead and remove the file. Go back to run the tool, see if it'll work now. So browse to, and it may have done if I went directly to the CAD file too. I've had that where it works if you go directly to the CAD file using this method as opposed to picking it from a layer in the map. So scroll over till I see the, where is the, all files, am I missing it somewhere? Yep, there it is. So there's the CAD file, add it. Again, base it on the layers there. Okay, okay. There we go, that worked. Notice it went ahead and added it back in after it ran the tool. So, and it came right in where it was supposed to. And this time it brought the whole drawing in. And notice all the feature classes are properly georeferenced. So there we go. Now you have seen how to georeference a CAD file in ArcMap. So I hope that has proven to be helpful. So with that, remember, we're here, AGIS Associates, which is now a part of the Davey Resource Group. We're here to help you consume the power place. Really, if you're trying to implement GIS technologies, integrate GIS, maybe you want to move from ArcMap into ArcGIS Pro, or you're trying to upgrade to ArcGIS Enterprise and want to configure Portal and all those kind of things, let us know. We're here to help you out. So you can reach out to us if you need any of these things. Get us on our website, www.agisassociates.com. Give us a call at 678-710-9710, or shoot us an email at info@agisassociates.com. Please remember, if you did like this video, found it useful, make sure to give us a thumbs up. Subscribe to the channel, and make sure, if you want to know when we release new videos, to hit that notification button. So with that, we look forward to seeing you in the next video.